Hi guys, welcome back to my YouTube channel. So today guys, we'll be talking about first law of thermodynamics. So we already stated the law in my previous video. You can check out the video if you have not. So today we'll be discussing on the calculations that are under the first law of thermodynamics. But before we go on, please, if you are just stumbling on this video, please kindly hit the subscribe button, and if you're a subscriber, thank you for subscribing. Please like and share to your departmental groups and to people that you know that this video will benefit. So let's dive right into the topic for today. So first law of thermodynamics. First law of thermodynamics states that energy can neither be created nor destroyed, but can change from one form to another. We've known these things right from our secondary school. That's the law of conservation of energy. That energy can neither be created nor destroyed, but can change from one form to another. So the mathematical expression of first law of thermodynamics is delta U equals to Q minus W. And our delta U is the change in internal energy. And the unit for calculating that is our kilojoule. Our Q is the heat added or given out. It's also in kilojoule. And our W is the work done by the system or on the system. And that is also in kilojoule. So it's been established already that the mathematical expression for first law of thermodynamics is delta U equals Q minus W. And our delta U is our change in internal energy. Our Q is the heat added to the system or lost to the surrounding. And our W is the work done by the system or on the system. And they're all in kilojoule. But there are cases whereby we would need to calculate our Q. And to get our Q, there's a formula for Q. But our Q is energy transfer due to temperature difference. Now, so the formula for our Q is MC change in theta, where M is the mass in kilogram. Our C is the specific heat capacity in kilojoule per kilogram degree C. And our change in theta is the temperature difference. But note that when our Q is added to the system, let me say when Q is added to the system, or when it is absorbed, it is positive Q. But please don't forget our Q is the heat. So let's say when heat is lost to the surrounding, it is negative Q, such that in your question it will be stated if the heat is added to the system or if it is lost to the surrounding. So the implication is that if our Q is added to the system, that means our final formula would be delta U would be, if it is added to the system, since our Q is plus Q, so that's plus Q minus W, which is still giving us our Q minus W. But when, so this is when Q is added to the system. But when Q is lost to the surrounding, the normal formula now is delta U equals to Q minus W. But now, when Q is lost to the surrounding, we have the minus Q. So that will be minus Q minus W. So this is when Q is lost to the surroundings. So that is when we want to calculate. Sorry, I didn't input this. This one is in degree C. Yes, that's the unit. So if we want to get, if there are questions that involve us getting our heat, so this is the formula that we need for calculating Q. But there are still some things that we need to put in place, and those things that we need to put in place is this. Yeah, so there are times we are done with it. So there are times we have to calculate our W2. So to calculate the W, which is our work done. Now our W is, let's write, so our W is the work done. Our W is the energy transfer due to force applied over a system. So the formula for this is W equals to P change in V, where our P is the pressure in kilobar, and our change in V is the change in volume in meter cube. So just like our Q, W also has a note, things that need to be considered. When W is, let me say, when the work is done by the system, or if it is expansion, then we can say it is plus W. But when the work is done on the system, or compression, we can say it is negative W. And the implication is that our normal formula is delta U, delta U is equals to Q minus W. So when the work is done by the system, if the work is done by the system, it causes an expansion to the system. So when the work is done by the system and is our, so that will be Q minus, in this case that is plus W, and this was minus times plus is minus, so it will take us back to our formula, which is, this is when work is done by the system. But when we have delta U, which is our normal formula, Q minus W, and when the work is done on the system, which causes compression, then we would have Q minus W, which will give us Q plus W. So this is when work is done on the system. So please, before we move on, we need to understand these principles. The first thing you need to understand is the mathematical expression, which is our delta U equals Q minus W. Then the second thing is the formula for Q, which is MC change in theta, where our M is the mass, the C is the specific heat capacity, and our change in theta is the temperature difference. That's change in temperature. Then if we want to calculate our W, we have pressure times change in volume, and our P is the pressure, which is in kilobar, and our change in V is the change in volume. So the principles that you need to note: when the Q is added to the system, or when it absorbs, then our Q is plus W. And for work done, when the work is done by the system, causing an expansion on the system, it is also plus W. Then when Q is lost to the surrounding, when it is lost to the surrounding, and when work is done on the system, we will say our Q is minus Q and our W is minus Q, which causes a change in a way to the normal mathematical expression. So let's move to the questions. A 5 kilogram turkey is cooked in an oven at 180 degrees C. If the turkey absorbs 3,000 kilojoule of heat energy and the oven does 500 kilojoule of work to cook the turkey, what is the change in internal energy of the turkey? So anytime you want to do any calculation, the first thing you need to do is write out the values that you were given. Yes, the first thing, write out the values that you were given. And please, you need to understand the question too. If you don't understand the question, then you might miss some things and you might get them wrong. So they said a 5 kilogram turkey. So in this case now we are given mass, which is 5 kilogram. Said a 5 kilogram turkey is cooked in an oven at 180 degrees C. Okay, let's say our temperature now is 180 degrees C. Said if the turkey absorbs 300 kilojoule of heat, what are we using to denote it? Q, which is 3,000 kilojoule. So please, now we need to know if our Q is positive or negative. Let's get it from the question. I said if the turkey absorbs 300 kilojoule, and I mentioned that if the heat is added to the system, or if it absorbs it, then it's a positive Q. So we can say this is plus 300 kilojoule of heat energy, and the oven does 500 kilojoule of work. Now it is the system that is doing the work. Work is not done on the system. It said if the turkey absorbs 300 kilojoule of heat energy and the oven does 500 kilojoule of work, so it is the system that is doing the work. So we know that now our W will be 500 kilojoule. Now, is our W plus or minus? If the system is doing the work, if the system is done by the work, then it is a positive work done. So we said, and the oven does 500 kilojoule of work to cook the turkey. What is the change in internal energy? Now, we already know that delta U is what we are asked to look for. So, like I said, if you want to do any calculation, the first step is write out the values that you are given. After writing out the values that you are given, that thing that you're asked to look for, what formula do you know that is associated to that thing that you're asked to look for? So in this case, we know that our delta Q, I said delta Q, delta U is Q minus W. Now, another thing that you need to watch out for is the units. Are the units right? Are they meant to be what they are? What they are? And I mentioned that our Q is in kilojoule, so this is perfect. Our W2 is in kilojoule, which is perfect. So from our unknown now, we have two knowns. So we have two knowns. We can use it to get our unknown. So this question is quite easy, straightforward. So now our delta U, we can easily calculate our delta U to be 3000 minus 500, which will be 2005 kilojoule. So that's that for this particular question. First thing, write out the values that you are given. The second thing, know your unknown and know the formulas that are associated with your unknown. Then substitute with the values that you have. So in this case now we have two knowns and one unknown, so it's easier to just input it to get our unknown and to remove. So our next question, a cake mix with an initial internal energy of 1000 kilojoule is baked in an oven at 200 degrees C. If the oven transfers 2005 kilojoule of heat energy to the cake and the cake expands and does 200 kilojoule of work, what is the final internal energy of the cake? So, like I said, first thing first, write out the values of what you were given. So, the first thing, like I said, a cake mix with an initial internal energy. So they said initial internal energy. Let's use I to denote initial is 1000 kilojoule. So this is baked in an oven of at temperature. Sorry, our theta is 200 degrees C. If the oven transfers 2000 kilojoule of heat energy to the cake, so Q said the oven transfers 2005 kilojoule of heat energy. So in this case, will our heat energy be positive or negative? Answer that in your mind according to what I've explained. So yes, according to what I've explained, our Q will be addition because it is added. It transfers. It's more like it's still adding. It's not lost to the surrounding. So our Q is T plus 2005 kilojoule. Oven transfers 2005 kilojoule of heat energy to the cake and the cake expands. In fact, from the word expansion, so we should know what our W should be. And the cake expands and does 200 kilojoule of work. But in this case, they give us two hints. The first one is that it causes an expansion, and the second one is that the system, the system does the work, like the work is done by the system. So, according to what I've explained, answer what our W will be in your mind. So it should be plus 200 kilojoule of work. What is the final internal temperature of the cake? So delta U F is what we are looking for. So in this case, we have initial internal energy. Like before they started baking a cake, there was an internal energy before. Like there was energy, probably energy transfer or something in the oven before. So and they calculated that to be like the data is 1000 kilojoule. Now this after now putting the what did they make a cake. After putting the cake and all the processes, they recorded the heat that was added, they recorded the work that was done. So to get that now, and we are now asked to look for the final energy, final internal energy. To get that, you have to know the initial energy for the cake. You know, the system already has an initial internal energy before the cake was added. So we need to know the one for the cake, the internal energy for the cake. So now the internal energy for the cake now, let's say theta UC will now be our normal Q minus W. So and we have our Q, we have our W. So we have 2005 minus 2000, which is 2003 kilojoule. But please note, what we have to look for is not the internal energy of the cake. What we have to look for is the final internal energy. So to get our final internal energy, that would be the initial internal energy of that oven plus our internal energy of the cake, which will now give us 1000 plus 2003 is now 3300 kilojoule. I hope you understand, and I hope there is no question so far. Please, if you have any question, kindly drop your question in the comment section and I will attend to them. So let's move to our next question. If you are asked to look for the internal energy of the system alone, please, you don't need to add. But since what we asked to look for is the final internal energy, so we needed to add the initial internal energy and the internal energy for the cake. Yeah, so we move to our next question. A kneading machine compresses dough to improve its elasticity. During the process, it transferred to the dough. It's transferred to the dough. That is, it is added. So our Q is plus 50 kg. Then said work done on the dough. In fact, aside from the fact that they said work done on the dough, they already mentioned that it compresses. So we should know that our W would be minus 30 kg. So we give it 2 hints. The first hint was that it compresses, and the second hint is that work done on the dough. So now what are we asking for? Our change in internal energy. So quite easy. Delta U equals to Q minus W. So delta U now. What's the Q? 50 plus either I add it or not, it's still the same. So minus what's our W? Minus 30. Please take note. Theta is now 50 plus 30. Now theta U is 18 kilojoule. So when it's the expansion and when work is done by the system, our work done is addition. And when it is compression or our work is done on the system, then it is minus. Yeah. So let's move to the next question. So our question 4. A mixer is used to whip 200 grams of cream from 20 degrees C to 30 degrees C. If the mixer uses 400 kJ of electrical energy and the cream's temperature increases by 10 degrees C, what is the change in internal energy? Assume the specific heat capacity of the cream is 3.5 kJ per kilogram degree C. So before we solve this question, there's this notion that I would like us to change as FST students. Most times we don't want to even see calculation in our courses anyway. And we just like cram the formulas and just go and pour it down the same way our lecturers taught us. And we don't try to understand the the topic. So when we now see like question that has like probably 2, 3, 4, 5 lines, in our mindset we get discouraged that we don't know what we want to write. But I want us to change that notion. We should know that in as much as you can like just go through it, you can just go through it, understand the question line by line, word for word. If you can do that, you understand that everything that you need is in the question and it's still as easy as it can be. That's all. Uh, that being said, let's move to our question. So, said a mixer is used to whip 200 grams of cream. Our mass is 200 grams. And you know our mass should not be in gram, should be in kilogram. From 20 degrees C to 30 degrees C. Our change in temperature is 30 degrees C minus 20 degrees C, which is 10 degrees C. Yes. So then if the mixer uses 400 kilojoule of electrical energy, so our work done is 400 kilojoule. And the cream's temperature increases by 10 degrees C. To just buttress this point, what is the change in internal energy? This is what we are looking for. Assume the specific heat capacity of the cream is 3.5 kilojoule per kilogram degree C. So someone might be asking, that's why is our work done 400 kilojoule? Why is not it? You know, I mentioned from the beginning of the video that our Q is the energy transfer due to temperature difference, and our W is the energy transfer by a force applied to a distance. So in this case, this is not due to the energy transfer is not due to temperature difference. Said if the mixer uses 400 kJ of electrical energy, so the electrical energy is the force that is applying to like to push to it. So if the mixer uses 400 kJ of electrical energy and the cream's temperature increases by 10 degrees C, what is the change? So in this case, it's not the system that is doing the work. The work is done on the system through the mixer. So this is our negative. Sorry, this is negative. So now what we are looking for is delta U, and we know our delta U is Q minus W. Are we giving Q in this question? No. So basically we have two unknown and one known. So out of these two unknown, is there anything we can calculate before getting to like do we have values that we can use to calculate one of the unknowns before we now calculate the second unknown? Yes. For our Q, which is MC change in theta. So do you have our M? Yes. Do you have our C? Do you have our change in theta? We have all of that. So we have 0.2. What's the C? 3.5. And what's the change in theta? 10. So this is 0.2 times 10. This is 7 kilo. So since that we have our Q and our W now, we can now calculate our change in U is Q minus W. This is now 7 minus 400 is 407 kilojoule. So can you see that it's not as hard as we think. What we need to do is just put down the question, understand the principles behind it, and we are good to go. So let's move to the next question. So a pressure cooker operates at constant pressure of 280 P equals to 280. Remember I said the unit for pressure is kilobar. So we are coming to that to change it. Said as the pressure cooks, steam expands. So we already know that our W is plus. Steam expands from 0.5 liter to 1.0 liter. So our I mean change in volume rather, not temperature this time around. Change in volume is 1.0 minus 0.5, which is 0.5 liter. And I also mentioned that this is should be in meter cube. So said the cooker transfers 200 kilojoule of heat, 200 kilojoule of heat to the soup. So it is added to the soup. Calculate the change in internal energy. So just our normal formula, Q minus W. So let's change this. 180 is 1.0.325 kilobar. So 280 now will be 2 times 101.325. So this will be the last question on first law of thermodynamics. So let's solve. A kneading machine compresses dough to improve its elasticity. During the process, okay. During the process, the internal energy of the dough is 250 kilojoule. The machine does, so from our knowledge, we already know this should be minus 50 kilojoule. In fact, they even mentioned double emphasis compresses. So the machine does 50 kilojoule of work on the dough. Calculate the heat transfer to the dough. So this is what we have to look for. And we know that our delta U is equals to Q minus W. And our delta U is 215 kilojoule. Is equals to, what's Q? That's what we're looking for. Then minus 15. So we have 215 equals to Q plus 50, right? So our Q is equals to 215 minus 15, which is equals to 200 kilojoule. So guys, this is where we'll be stopping for first law of thermodynamics. But before we wrap up, I would write a question and I would love if you can solve the question and give me the answer in the comment section. If you made it to this point, kudos to you. That's a very good thing to do. So kindly attempt this question and please put your answer in the comment section. And guys, don't forget, if you have any question at all on first law of thermodynamics, please do not hesitate to drop your question in the comment section and I will attend to it. Guys, please, if you've not subscribed to this YouTube channel, kindly hit the subscribe button. And if you're a subscriber already, please like, comment, share to your departmental groups and to people that you know that the video can benefit. See you next time. Bye.